Thanks for joining. Today I'm going to talk about Jupyter in the Wikimedia ecosystem. To those 12 minutes that I have. The structure of the talk is this. So this is the rough timeline I'm striving to. Let's start with motivation. So if this has two parts, mission alignment and reproducibility. Let's start with the mission alignment. Jupyter, if you look at the mission of Jupyter, it is there to support interactive data science and scientific computing across all programming languages, whereas Wikimedia imagines a world in which every single human being can freely share in the sum of all knowledge. And I'm a data scientist interested in integrating open research and education workflows with the web, so we have correspondence here and here, here and here, and then here and here. And that brings us to a synthesis that we could frame as how can we leverage Jupyter-based open research and education resources to support the Wikimedia mission and vice versa. Now, the second part of motivation why we do this is reproducibility. This was the subject of prior JupyterCon talks, and I don't have the time to go into it, but I encourage you to explore those links. Suffice it to say that progress has been made. So, Jupyter in the Wikimedia ecosystem. The Wikimedia ecosystem is the ecosystem around Wikipedia and its sister sites, roughly organized by information channels. So you have the encyclopedia, you have the media repository, you have the database, and so on, similar to how Jupyter is organized around the different languages. And then there's communities that interact with, across all of those. Some simple interaction between the two ecosystems is that Wikipedia has entries about programming languages. It has entries about Project Jupyter itself. So here's a Korean version of it, about people that are involved, related projects. There's a Wikimedia Commons category for that, which has media files. And by now you may have noticed that this presentation is run on JupyterHub, which is the one that is actually run on the Wikimedia cloud. So now that we have done the obvious ones, we can dig a little deeper. For that, I would like to highlight Jupyter in the context of the Wikidata knowledge graph. So there is, if you don't know what Wikidata is, in short, it's the the database that anyone can edit, similar to the Wikipedia being the encyclopedia that anyone can edit. And otherwise, there is a 7-minute introductory video that gives basics about Wikidata. Then I encourage you to look into that. So here then is a front end to Wikidata called Wikidata for Digital Preservation. There you can search for Jupyter-related content, and it will give you a number of things. If you click on that, Jupyter Notebook, for instance, it gives you structured information about this. It has this identifier. It's a file format. It has this media type, application X, IPython, JSON, and so on. There's another front end called Scholia that basically looks at the scholarly literature about a topic. So here we have the topic of Jupyter Notebooks, and then you can explore that. We're actually in the process of upgrading Scholia, and Jupyter-based approaches like Voila and Papermill are amongst the things we're considering. So if you have strong opinions on that, let us know. Now, some examples from the Wikipedia world. In lots of Wikipedia articles about programming languages, you have code snippets that illustrate certain aspects of the programming language. So here we are in Python, data structures, list append. This is given verbatim in the Wikipedia article, but it's not actionable. So if you're reading this as a user and you're not too familiar with that data structure, you might wonder, is this correct? And we want the Wikipedia users or Wikimedia users to be able to verify every piece of information, because that if every user is able to verify it, then this enhances the quality of the information. So for pieces of code, a simple mechanism to make it verifiable would be to think about running that code in Jupyter Notebooks. Yeah, and so here we have the list. Now we try to append to it, and yes, it worked. So that's the kind of illustration that would probably enhance the perception of articles like that. A similar case here is we have a spline algorithm here. This text is again taken verbatim from the Wikipedia page, except that I've commented out the print commands here. So if I run this, then we see this spline curve show up, just like it is described in the article. And this interaction and being able to play with the parameters, that's certainly educative. In the Wikimedia ecosystem, very often algorithms are illustrated in a different fashion. So a classic example is GIFs. Here is a whole category of animations of sort algorithms. And they do their bit. They are certainly helpful. If you don't know the algorithm at all, then looking at those GIFs for a while gives you some idea of what is happening. But the parameters of the animations are essentially statics, and the underlying data and code are not shared or not easily shared or accessible. And so basically the way in which the users can interact with those animations is limited, and Jupyter has more options here to interact with them. Another example is here, one of those sort algorithms, beat sort, actually has written down an implementation in Python, but yeah, again, it's not actionable. So then here I have a collection of other examples of where Jupyter resources pop up in the Wikimedia universe, from the Wikimedia Foundation to French Wikibooks and German Wikisource, or Wikimedia Fabricator and Python Quiz and user templates, all of that. I encourage you to look through that. Yeah, we have to move on. There are certain barriers to reuse of Jupyter resources in the Wikimedia context. Some of them relate to dependencies, especially software dependencies, and this is still a problem, but with tools like Reproduce Me Git that I mentioned at the beginning, we're getting better. Another problem is licensing. Many notebooks do not have clear licensing, or the licenses that they have are more suitable for code than for documentation, data, or other associated materials. And if you're talking about using Jupyter notebooks to explore data sets, then this brings another dimension to it. They have their own licensing. Somehow the Jupyter Notebook has to go to the data set, and then whatever it finds there has to be brought into the Wikimedia ecosystem. So it's a three-way problem here. And sometimes this works and sometimes it doesn't. And I've outlined two cases here. One where essentially copyright stood in the way of using certain materials, and here where an opportunity where a specific notebook could be used as an example for a more general problem, like determining an earthquake's location as an inverse problem. So that could illustrate the Wikipedia article about inverse problems. Then Wikimedia in the Jupyter ecosystem. So when GitHub announced that the integration of Jupyter, one of the prominent examples was a Wikipedia-related notebook. Then Wikipedia, of course, is referenced to and from the entire web. And so in many GitHub repos with a Jupyter notebook, you will find some reference to Wikipedia. Or if someone is writing a demo of certain software libraries, then very often this involves fetching something from Wikipedia or Wikidata or some other open source. So here we have an example. Jupyter has lots of kernels for different languages, mostly programming languages, but also query languages. So here's Sparkle, and we can use this Sparkle kernel to actually run a Sparkle query that gives us Wikidata topics for which we essentially don't have images. And so if we look at those, and these are algorithms or formulas and things like that. If you look at those, we can then consider whether suitable Jupyter resources already exist for this kind of topic. And if so, we can look into integrating them into the Wiki ecosystem. And if not, we can think about creating maybe such resources. So in terms of potential for further integration, we can do essentially more of those examples that I've showed. We can think about what to do with the Jupyter resources that already exist. So if you wrote a Jupyter notebook for educational purposes, well, then those educational purposes might well be served through Wikimedia projects as well. So consider how you could integrate there. Then if you did something to enhance Jupyter functionality, that enhancement would probably be of interest to the Wikimedia community as well. So I propose that we start thinking about systematically integrating existing Jupyter resources into the Wikimedia ecosystem, and also thinking about creating Jupyter resources to fill the relevant gaps in the Wikimedia ecosystem. Such activity then also requires to think about things like how to cite and describe Jupyter notebooks, but progress has been made there, as mentioned in the introduction. Then we could also think about adding more Wikimedia to Jupyter. So in addition to having Hello World examples, you could think of Hello Wiki examples, where someone actually fetches some data from Wikipedia or Wikidata or so. Or I saw in a Jupyter discourse that someone wants to keep track of the registries of Jupyter-related installations, and Wikibase is something that could be used for that. Or we could look around for other projects like Rosetta Code that covers all project languages, and and already uses media. It covers all programming languages, and it already uses MediaWiki. And so if it had a Jupyter binder layer, then that would make the experience of the programming language much deeper. I have lots of further notes, not much more time, so I'll scroll over them. I encourage you to explore them. And the conclusion is there's lots of interactions already between the Jupyter and Wikimedia ecosystems. They happen in multiple and diverse contexts. And now is a good time to start thinking about doing this more systematically. I would like to credit two main sources. One is the images. Those images that I have not created myself. There's a Wikimedia category for all the images that are used in this talk. And then in general, I would like to thank the open communities that support Jupyter, Wikimedia, and the ecosystems around them. If you want to contact me, you're most welcome to do so, and the details are here. Thank you very much.